All right. So regarding the coding systems, let's quickly write these things down. We discussed about this earlier. So have the heading coding system. And you can write this highlighted part. Binary codes are used when storing numeric, alphabetic, special character images, and sounds in internal storage device of a computer. People, you only need to copy this part, right? Okay.
Done, sir.
Right, okay. So let's go for forward. Okay, let's go to write the binary coded decimal. Hold on. Yeah, let's go. Let's do it like this, people. It's better you write this sentence, then put Roman number 1 and have this heading. Not actually a heading, it's kind of the first coding system. And in front of your heading, within brackets, it's better you say 4-bit. 4-bit representation. 4-bit representation. Right, within brackets, 4-bit representation. Four-bit representation. Then you can write these things. Let me know when you are done, people.
Done, sir.
Right. So can we move forward? Anyone who is still writing? Right. If you are done with this sentence, you have to copy down this table plus the example. You may finish it off, people. I'm away for a minute, right? I'll be right back. Let me know when you are done, people.
Done, sir.
Okay, two are done. How about the others?
Done, sir.
Right, okay. So moving forward, let's write about the ASCII as well. It's a second coding system, and like we done previously, after this heading, you have to write this is 7-bit representation. 7-bit. 7-bit representation. Right under that, you can write this.
So in the previous binary coded decimal one, did you use such a answer? I didn't hear that time.
Yeah, we use a 4-bit representation with
Okay,
the
sir.
heading, right? So this is 7-bit representation. Are we done, people?
Yes, sir.
Okay, anyone who is still writing?
That's okay.
All right, so moving forward, you have to write this example, people, and I have to tell you something about this example as well.
Your candy.
Thank you, Susan. So here they have shown you how they can use the ASCII code system to represent a text, right? Because ASCII code system is majorly to represent the text, right? So when they are trying to represent a text, the one that they are referring is this huge table at the end of your lesson, right? So you don't need to remember this table, which is not possible. But I want you to have your concentration on these ASCII characters and the decimal numbers regarding it, right? ASCII character and the decimal number, right? So like if you think about if you scroll down, you will find the numbers over here, 0, 1, 2, 3. These are the ASCII characters. That means to represent the 0 in ASCII. Okay, so thank you. So reduce the volume, reduce the volume.
You've gotten so tall.
More. You have to do it more. Do it more, Monica. It's better you go to that table so you can watch it without a problem.
I'll keep it here.
So take the bag away, otherwise it will roll down. Okay, reduce a little. Reduce it further. Reduce. Okay. That's enough. Okay. Oh, that's too much. That's too much, Suzu. Okay, sorry for that. And people, and you can see like here, this represents the 0, the ASCII character, that means the 0 on your keyboard is represented by the ASCII value, which is equals to the decimal 48. So that means if you can write the decimal 48 by 7 bits, that means using 7 ones and zeros. So that will represent the character 0 in ASCII, right? And if you go further, you will find the alphabetical, the letters in capitals. So capital letters, the simple A represents the decimal value 65. That means that decimal value 65 means the ASCII value converted into the decimal, it represents 65. So, and you can see these letters are in order, right?
These candies.
When capital A is here, capital B is the next character. So it is in order. As well as when it comes to the simple letters, it goes the same way. See, simple A, then it flows the same way. So simple A represents 97. So we can say, okay, simple B represents by 98. Right? So that nature is there in the ASCII as well as EBCDIC coding system. Right. So that is the basis that they have used to represent the letter school, the word school over here. All right. So look at that. So they're asking you to represent the school S capital, other letters are simple. So capital S represents by the 83, right? So that means capital S represent by ones and zeros, which represents 83 in decimal. So likewise, simple C represents 99, So if C is 99, the letter H going to represent 104, right? Because C is 99, C, D, E, F, G, H. So after 6 characters. So 99, D, E, F, G, H. So it goes to the 104 to represent H. And the simple O, 111, simple L, 108. So here they have shown you the representation. And here they have written the lengthy binary code for the word school. Is that clear, everyone? How they are like representing things in ASCII?
Yes, sir.
Right, great. So let's write about this example, because these kind of calculations can be there in your exam paper, right? So you don't need to like go like step by step when you are doing the question regarding that, right? But it's better you write these steps over here so you can remember how things are happening, right? Okay, so copy it down and let me know when you are done, right? Right, one is done. How about others? Okay, anyone who is still writing this?
Totally done, sir. Totally.
Okay. Okay, let's move forward. The third coding system, it is EBCDIC. And this is how many? 8-bit representation.
Say 18. Oh, 8. Sir, is that a bracket or is it 18, sir?
Yeah, hold on this one. It's the bracket. And you have to say 8-bit. 8-bit representation, right? So BCD is 4-bit representation, ASCII is 7-bit representation. This is 8-bit representation. Okay. Are we done? It's only 2 lines for you to write. Okay, anyone who is still writing? Okay, great. Let's move forward.
Sir, sir, could you give me a moment, sir? I think to take a screenshot.
Right, okay. Okay, Rizwan. Go on.
Okay, sir. Okay, sir. I got a screenshot.
Are you clear, Rizwan?
Yeah, sir. It's
Right,
clear.
great. So we are moving forward. The final one, the Unicode system. And there you have to write 16-bit representation. Right, so 16-bit representation. And under that, Let me know when you're done, people. All right, one is done. How about others?
Done, sir.
Okay. Anyone who is still writing? Right. Can we move forward? Anyone who is still writing? Okay. So here we go. Have this one. Right. So we have to write some examples as well, since it has got a lot of things as the data. Right. So regarding the example, it's better you write this. Let me see what we can write through here. let's write it like this. I'll read it to you, right? So we can't sum this up over here. Pictures and graphic data. So under that, there are many different colors. There are many different colors. There are many different colors. Many different colors. In a picture, right? There are many different colors in a picture. Full stop. To represent each and every color and its shades. To represent each and every color and its
Sir, in a picture,
to represent these colors and the shades of them.
Sir, in the picture to represent.
Come again, Rizwan.
Sir, in a picture to represent each and every color. After that, sir.
Hold on. Now I have jumbled the thing. I said like this. In a picture, there are many different colors. Great, that's good. In a picture, there are many different colors. To represent each and every color and its shades. And its shades. And its shades. Computer can use a unique Unicode.
check.
Got it? Okay.
Picture of the dog.
That's nice. So then comes this sound. Yeah, you can write this part. Plus, it's better you draw this diagram as well. And what it represents by this? Now, they says the sound is kind of an analog wave, something like this. So what the computer is doing is like each and every point of the analog wave will be converted into a corresponding binary code. Right, so each and every tiny place will be represented by, now if you think about this place, it is from 3 and 1, the coordinates are, and that 3 and 1 will be represented like this. So likewise, to convert an analog signal into a digital one, computer does this thing for each and every point of the analog wave. Got it, people? Yes, everyone, is it clear?
Yes, sir.
Right, great. So you can write the highlighted part and plus you can draw the picture. Yeah, Sanushi, it's like this. Sanushi is asking to describe the part of the sound, the graph kind of thing. So Sanushi, sound is generally happens on this manner. We call this the analog wave. So each and every point of this analog wave will be converted into a binary code. How they are going to convert it?
You really like taking.
They have given it right over here, right? So like this specific point is considered as the third 3, 1, the position, the coordinates. So that 3 is written in a particular code and 1 is written in a particular code, right? It's true they haven't mentioned it in hexadecimal over here, but what they have shown is like this is the way that is going to happen for a sound. Got it, Sanushi? Right. Okay, one is done. How about others? Anyone who is still writing? All right, seems no one. Right, moving forward. Let me clear the annotations. Yeah, that will be all. Right, so that is the things that we have to do regarding the number system lesson. Right, so I want you to try this small number, this small activity over here. Right, since we are done with the lesson. Right, so let's give it a try, people. You don't need to do this explaining part. So do the first 4 questions here. You can just write the activity and you can write the activity and the page number. Then you can just write, its page number is 101. You don't need to write the question, people. Yes, people, how's the situation? Are we done? Can we discuss? Anyone who needs more time? Okay, so I'm going to try the things. Give me a second, people. Right. So the first question, it says if a character is represented by 1, 5 zeros and 1 in ASCII system, what is the ASCII code for letter F? Now, what is the easiest way to solve these things, people? So if this is the one which represents A, let me take a different color. Yeah. This is the one which represents A. It's better we convert this thing, into the decimal values, right? So I got 1, how many zeros? 5 zeros, right? Yeah, 5 zeros and a 1. Right? So if you think about the place values, what's going to be the place values? It has 1, 2, 4, 8, 16, so this is going to be 32 and this is going to be 64. So what it's going to be, what are the things that we are going to add up? It's going to be, we are going to add 64 and 1, right? Which gives us the value of A, which means 65. So A is equals to 65, right? Then we are going to find what's the value for F. So the codes are, since it is ASCII, we can assume that. Assume means we can calculate it. A, B, C, D, E, and F. So that means B is 66, C is 67, D is 68, E is 69, and F is 70. So now you need to what? Convert 70 into binary. Now, how we are going to convert 70 into binary? Shall I show you a shortcut to do this? Right? Look at this. I'm going to write the place values. 1, 2, 4, 8, 16, 32, and 64. These are the place values in binary. Then I'm going to write, or like I'm going to make 70 out of these things. So I'm going to create 70. I need 64, and I need 4, and I need 2. So this is going to represent 70. So your answer is going to be this. People, is that clear?
Yes, sir.
Right.
Yes, sir.
Okay. Who got this correctly? Let me see. Raise hands. All right, there are many. That's great. That's great. Okay, so if you need to have any clarification regarding this, so be careful, right? So you can, I'll give you a minute for you to put it into your book, right? Then I'm going to do the second one. All right, I'm going to clean this thing. Does anyone need it to be keep a little bit further? All right. So the next one asks, what is the largest number presented in BCD? So the largest number is what? It's the ninth, right? This represents 1001, right? So BCD is a coding system which use only to represent numbers from 0 to 9. So the largest number that is representing is 9. And the third one asks, what is the minimum number of bits required to present a hexadecimal number? What is the minimum number of bits required to present a hexadecimal number? And we know to represent a hexadecimal number, if we consider A can be represent, A means 10. 10 is going to be represent what? 8, no 4s, no 2s, and only 1. I'm sorry. 8, no 4s, but there is a 2 and no 1s. And they are asking what is the minimum number of bits required to present a hexadecimal number. Now it's kind of a tricky if we think it like this. If you think about the hexadecimal number, we can take 1 is also an hexadecimal number. So to represent 1, only 1 bit is sufficient. To represent 2, we need 2 bits, 1 and a 0. But to represent 1, there is only 1 bit. If you are arguing up to that point, you can say just 1 bit is enough. If you are asking about the minimum, then 1 is enough, right? But generally, when we are representing a hexadecimal in binary, we use 4 bits. Okay, people, are we clear up to that point?
Yes, sir.
Right. So then the fourth one. So the fourth one says, if, this particular one represents B in ASCII code. What is the ASCII code for letter L? Yeah, something very similar to the previous one, right? The first one. So now this represents what? Letter B, capital B, right? So capital B represented by 1, 4 zeros and 1 0. 1, 4 zeros and 10. Right? And then it says to find the letter L. Right? So this is B. And B represented by, let's convert this into the binary. So the place values are going to be 1, 2, 4, 8, 16, 32, and 64. So then we have to add up the 64 and the 2, that means 66. So B is represented by 66. C, D, E, F, G, H, oh, that's quite big. I, J, K, and then it's going to be L. So it's going to be 66, 67, 68, 69, 70, 71, 72,
76.
73, 74, K 75, and L is 76. Right? Yes. So 76 can be represented as how? Let's do that trick again. 1, 2, 4, 8, 16, 32, and 64. How we are going to create 78 out of these things? We can have 61, 64 for 1. So like there are 64s, we need another 12 to create 76. We can take 8 and the 4. So rest of the places represent zeros.
0.
Yes. Yeah. So that represent the letter L. Right? Okay, people. Is that clear?
Yes, sir.
Yes.
Right. Okay. Okay, so let's write this question as the very last question of the number system, right? So let me type it for you so you can write it. Seems the writing is easy for me than typing. So let's have it like this. If C represents as 0, 1, 0, 0, 1, 0, write the ASCII code of word cab. If C represents as 0, 1, 0, 0, 0, 1, 0, write the ASCII code of word cab. That's going to be your last question regarding this. You can do the calculation and send me the answer through the chat. Be careful when you are typing the ones and zeros. It's quite lengthy. You need to type 21 ones and zeros. Yes, Dilendya, it's the correct answer. Very good. Yes, Sanushi, that's correct as well. Sanushi, hold on. Am I missing something over here? Yeah, people do not forget the 7-bit representation. Sanushi, I think you have missed a 1 0 when you are representing A, the letter A, as well as B. People, since it is 7-bit representation, do not reduce anything. It should be a 21-bit code. Sanushi, in your answer, I think you have swapped the places of 1. You have put 1 under the 64 instead of 32. Right? Be careful. Be careful. Kitme, you made the same mistake. Like same mistake means you haven't represented in 7 bits. Mihini, that's the correct answer. That's correct. That's correct. Yes. Rison? Yeah, I think you have made the same mistake. Did you? Let me see. Let me see. No, Rison, there are small mistake regarding this.
Such as
I think, hold on. I think the representation of A is wrong, as well as the representation of B. Yeah, let me do this for you. Let me do this for you. Hold on.
answer is there's small mistake. Okay.
So yeah, so like 0, 1, triple zeros, 1 0. Horizon, still you have a problem. Hold on, don't panic. This is C. So this represents what? This is 34, isn't it? What I'm saying it is 34. If the place values, this is 1, 2, 4, 8, 16, and this has 32, and this is 64. Right? So what are we considering is like 32 plus 2, 64. So we need the letter B and letter A. So letter B means 1 less than 34, that means 33. So 33 can be represented as 0, 1, 4 zeros and a 1. Yes, now Rizwan, now it is correct. And 32 can be represented as 0, 1 and 5 zeros.
Sir, the last one.
Right? So this represents A. Yeah, Rison, if it is 1, you are going to have 33. Because C is 34, Rison.
Yeah.
33 represents like this and 32 represents only 1 is needed on the 32nd position and all other things are zeros. So what's going to be the answer? Cap can be written as how? 0, 1, 3 zeros, 1 0, that is C. And then A I have to write. That means 0, 1, 5 zeros. And then B. That means 0, 1, 4 zeros and a 1. Right? So this is going to be your answer.
Excuse me, sir.
Yes, Dua.
Sir, can I leave because I have a class right now?
Yeah, and I'm going to exit the session as well. Sanushi, yes, Dua. Okay, Sanushi, it was my mistake. I was yeah, it was my mistake, Dua. Sanushi, but Sanushi, the answer that you have given me earlier, like lacking of 1 0. Lacking of 1 0, Sanushi. Earlier you have said 0, 1, 3 zeros, 1, 0, then 1. One of the 0 is missing in your earlier answer. Sorry, Sanushi. I think I have missed a second time. Yes. Right. Okay, people, is this clear?
Yeah.
Right, great. So by next week, we are going to start the new lesson, the 4th one, right? So I'm going to end the session from here just for today, right? So I'll see you next week for the very same time, right? So for that, thank you very much, people.
Thank you.
Thank you,
You're
sir.
welcome,
Thank
sir.
you, sir. Goodbye, sir.
Right, okay,
Goodbye.
people. Thank you very much. Goodbye.
Yes. Sir, you have put in this recording.